Okay, so we've talked about Vesper theory and bonds and hybridization, but now we kind of need to understand why atoms make the number of bonds they do. And that discussion is really all about electrons, right? So we really have to understand valence electrons and particularly understand how valence electrons really connect with the octet rule. So the octet rule says that atoms tend to gain, lose, or share electrons so as to have 8 electrons in their outer electron shell. So think about that. They can gain or lose electrons or share. And we're primarily going to be talking about electrons being shared. So the key here is we're really connecting how many valence electrons an atom has and what we need to do to go from how many valence electrons it has to get to 8. Okay, so let's take a look at some of the main elements that we're going to be looking at. First, we're going to start with carbon. Okay, so carbon has an atomic number of 6. If we think about its electron configuration, 1s2, 2s2, 2p2. Okay, but again, that's not the key number here. The key number we need to talk about is how many valence electrons does carbon have? Carbon has 4 valence electrons, okay? It can be hybridized to sp3, sp2, or sp, but it has 4 valence electrons. So how do you get to 8? Well, you need 4 more electrons to go from 4 plus 4 to get to 8. So how do you get 4 more electrons? You get electrons through bonds. So carbon with 4 valence electrons will share another 4 electrons by making 4 bonds, and that will get to the octet rule of having 8 electrons around it. As we move up in the periodic table and talk about nitrogen, right, atomic number 7, but again, the key is the number of valence electrons nitrogen has. Nitrogen has 5 valence electrons. So how many bonds does it need to get to 8? We need, or how many more electrons does it need to get to 8? We need 3 more electrons. And how do you get electrons? Through bonds. Okay, so nitrogen will then form 3 bonds and then have 1 lone pair. So what you're going to notice here is there's always going to be 4 things around our atoms. Okay, what's nice about organic chemistry is we're really only dealing with atoms that are sp3, sp2, or sp hybridized. So they need to have 4 things around them, all right? So for nitrogen to do that, it will have 3 bonds and 1 lone pair, all right? If we look at oxygen next, all right, oxygen will have 6 valence electrons, okay? So we've moved over 1 column in the periodic table. How do we get to 8? We need 2 bonds. So oxygen will share electrons with 2 atoms, forming 2 bonds, and then the rest of its electrons are in lone pairs. When we talk about halogens, like fluorine, all our halogens have 7 valence electrons. Okay, they all have 7 valence electrons. They only need 1 more to get to 8, right? So halogens will form 1 bond, and then the rest of electrons are represented by lone pairs. All right. So what you'll notice here is that all of these are going to have 4 things around it, right? So we can use this model. It's from like general chemistry where we use A, X, and E. So A stands for the central atom, right? X is the number of surrounding atoms. And then E is the number of lone pairs. Okay? And what you notice in all of these, X plus E is always going to equal 4. And that will really be determined by how many valence electrons you start with. Carbon has 4 valence electrons, so it needs 4 more. It does that by making 4 bonds, right? So carbon will have 4 bonds. Nitrogen has 5 valence electrons. It needs 3 more, so nitrogen will form 3 bonds and then have 1 lone pair. Okay. Oxygen has 6 valence electrons, so oxygen will have 2 bonds to something and 2 lone pairs. Okay, and then halogen, like fluorine, will have 1 bond to something and then it'll have 3 lone pairs. All right. So what we really need to do is talk about how are we counting electrons, right? So when we're counting electrons, for the octet rule, okay, and we're going to talk a little bit later, we can count electrons differently when we're talking about formal charge, but when we're counting electrons for the octet rule, a bond counts as 2 electrons, and a lone pair counts as 2 electrons. Okay, so when we're counting electrons for the octet rule, a bond counts as 2 and a lone pair counts as 2. So if you remember in our discussion, we started talking about the octet rule. Atoms want to have 8 electrons around it. So if carbon has 4 bonds, it's got 2, 4, 6, 8 electrons around it. Check for the octet rule. Nitrogen will have 3 bonds, 1, 2, 3, and a lone pair, 2, 4, 6, 8, follows the octet rule. Oxygen will have 2 bonds and 2 lone pairs, 2 bonds, 2, 4, lone pairs, 6 and 8. Again, that follows the octet rule. And when we talk about halogens, 1 bond counts as 2, 2, 4, 6, 8. Again, we have 8 electrons, we follow the octet rule. So what you're going to see is when we talk about bonds, carbon, nitrogen, oxygen, halogens, right, they want to follow the octet rule. So carbon is always going to make, right, carbon is going to have 4 bonds and 0 lone pairs when it's neutral. Nitrogen will have 3 bonds and 1 lone pair when it's neutral. And oxygen will have 2 bonds and 2 lone pairs when it's neutral. And then halogens will have 1 bond and 3 lone pairs when it's neutral. Because this situation means that they all will follow the octet rule. Okay, so that's how we count electrons when we're talking about the octet rule. All right. Now, another concept we have to talk about is formal charge. All right. So over here we talked about counting electrons for the octet rule. And that's important when we think about basic bonding that's going on. But you're going to see we need that to understand how many bonds everything makes. But a lot of times we're going to have to calculate charge. That's called formal charge. Okay? And we count electrons differently when we're trying to determine if an atom has a formal charge or not. All right? So when we're counting formal charge, when we're counting electrons for formal charge, a lone pair counts as 2 electrons, but a bond will only count as 1 electron, right? So the way I like to think about this is when we're counting for the octet rule, we're talking about things being shared, right? So, you know, if my wife and I have money, we have a joint checking account, that money is shared between both of us. If I have $500 in my savings, I have 500, she has 500, right? Because we're sharing that money. But there's still only $500 there, right? Formal charge is kind of like, what's the real situation? If there's $500 in my account for 2 people, well, really, I have $250 and she has $250. And that's the scenario with a bond. A lone pair, the electrons only belong to the atom. But a bond, we're sharing 2 electrons. So technically, 1 electron belongs to 1 atom, and the other electron belongs to the other. Okay? So octet rule, bonds count as 2, lone pairs count as 2. But when we're determining formal charge, a lone pair counts as 2 and a bond only counts as 1. All right, so let's look at a few examples here where we're counting electrons to understand how bonding occurs, right? We want our atoms to follow the octet rule. So if we look at carbon, so we're looking at carbon here. Carbon can be sp3 hybridized, sp2 hybridized, or sp hybridized, all right? So we see the central carbon has 4 bonds, sp3 hybridized, 4 different bonds. Here it has 3 different bonds, 1 double bond, a pi bond, that's sp2. And this carbon is only connected to 2 atoms, right? That has 2 sigma bonds and 2 pi bonds. Regardless, they all have 4 bonds, right? So our carbon has 1, 2, 3, 4 bonds, 1, 2, 3, 4 bonds, 1, 2, 3, 4 bonds. So all of these carbons here, right, all of these carbons have 4 bonds, so they follow the octet rule. All right, simple. Now let's talk about formal charge, okay? Formal charge. So to calculate formal charge, we really need to talk about how many electrons does the atom have versus how many does it want to have, okay? So to calculate formal charge, it's really a simple formula. It's the number of valence electrons it wants, right? We get that from the periodic table, minus the number of valence electrons it actually has. And that's how you determine formal charge. And again, when we're calculating charge, we have to count electrons this way. So it's the number of valence electrons that the atom wants versus the number of valence electrons it actually has. So we look at carbon, the structure we see here, we have 4 bonds. Those each count as 1. So this has 4 electrons. It wants 4, so there's no charge on that carbon. Same thing here. It has 4 bonds. It wants 4, so there's no charge. So all of these species are neutral, all right? Okay, so now let's take a look at a charged species here. So here is a carbon that only has 3 bonds, okay? So let's first talk about the octet rule. Does this follow the octet rule? When we're counting electrons for the octet rule, each bond counts as 2 electrons. We have 3 bonds, so we have 1, 2, 3. We only have 6 electrons. So this does not follow the octet rule. Okay, and that's going to see, we're going to see a little later that means that this is going to be pretty reactive, right? We know that atoms want to follow the octet rule. This one doesn't. So this charged species is called a carbocation, and that carbocation is going to be pretty reactive. But now let's look at formal charge. So formal charge I'm indicating here by writing a plus. And for organic molecules, they're either neutral, where we write nothing. They usually will have a +1 charge, where we write a plus, or they have a minus, and we just write a minus. So we're never going to write a +2 or a 2 plus, because we're not going to see that, right? We don't write a +1 or a 1 plus. We simply just draw a plus sign or a negative sign, okay? So now to talk about charge, right? Carbon wants 4 valence electrons, but how many does it actually have? Each bond here counts as 1, so there's 1, 2, 3 bonds, 4 minus 3, so this gives us a +1, it gives us a 1. That's why this species has a positive charge, okay? If we look at our next example here, okay, so here we have a carbon that has 3 bonds and 1 lone pair. So let's first determine if it follows the octet rule, okay? Again, for the octet rule, every bond counts as 2, and the lone pair counts as 2. So we have 2, 4, 6, 8. So yes, this does follow the octet rule. Okay, but now let's look at the formal charge, right? We can already see what the formal charge is. How many valence electrons does carbon want? It wants to have 4 valence electrons, right? It's in the fourth column that we talked about on the periodic table. But how many does it actually have? Well, we've got 1, 2, 3 bonds. Those each only count as 1 electron each. So 1, 2, 3 electrons, and then 1 lone pair, 4, 5. So 4, how many does it want, minus how many does it have, is 5. So that's a -1. So what that means here, right, is we have to put a negative sign somewhere near that carbon atom to indicate that that carbon has a negative charge. All right? So again, we see carbon has 5 valence electrons. It has 3 bonds and 1 lone pair, therefore a negative charge. A question I have for you is, what could I replace this carbon with so it is neutral, right? The way this is drawn, what atom could we replace this with so it's neutral? What wants to have 5 valence electrons? If we look back up here, what wants 5 valence electrons? Nitrogen, right? So if I drew this same structure over here with a nitrogen, if I drew a nitrogen with 3 bonds and 1 lone pair, this would be then a neutral species. It has 5 valence electrons and it wants 5. So if that was a nitrogen, that would be neutral. All right, so let's look at oxygen and nitrogen here. Again, let's count electrons to follow if it has the octet rule or not. Let's do the octet rule first. Again, octet rule, bonds count as 2, lone pairs as 2. Bonds are 2 electrons. LP, lone pairs, are 2 electrons. So let's count the octet rule. So oxygen has 1, 2, 3, 4, 5, 6, 7, 8. Yes, that follows the octet rule, right? And here we see that's when an oxygen is sp3 hybridized. When it's sp2 hybridized, that oxygen still has 2 bonds and 2 lone pairs. 2 bonds here, that's 4 electrons. 2 lone pairs, there's another 4. So yes, that does have, in fact, the octet rule. This does follow the octet rule. Counting nitrogen here, again, 2, 4, 6, 8 follows the octet rule. 2, 4, 6, 8 follows the octet rule. 2, 4, 6, 8 follows the octet rule. Okay? So all of these species here follow the octet rule, right? Which we can see here. So let me erase, right? All of these follow the octet rule. So they're all neutral. I don't put a plus sign or a minus sign. All right. Now let's talk about formal charge. When we talk about formal charge, again, it's how many it has or how many it wants versus how many it has. Okay, so we know that oxygen wants to have 6. We know that nitrogen wants to have 5, right? How many does it have here? Again, bonds only count as 1. So we have 1, 2, 3, 4, 5, 6. Check. That is neutral. 1, 2, 3, 4, 5, 6. Check. That oxygen is neutral. When we look at nitrogen, that wants to have 5. How many does it have? 1, 2, 3, 4, 5. Neutral. 1, 2, 3, 4, 5. Neutral. 1, 2, 3, 4, 5. Neutral. Okay? So everything at the top here, right, these are follow the octet rule, and they are neutral. Okay? Great. Now let's look at some charged species here. Okay, so obviously I've already provided the charge on them, right? You can see that we've got a plus sign here and a plus sign there. Okay, so let's talk about the octet rule. Let's look at carbon. Octet rule, bonds, everything counts as 2. Carbon has 4 bonds, 1, 2, 3, 4 bonds. So that has, each of those count as 2. Carbon follows the octet rule. What about this oxygen? It has 1, 2, 3 bonds, times 2 is 6, plus another lone pair is 8. Oxygen also follows the octet rule. That's great, okay? Let's look at formal charge now, right? Carbon wants to have 4. How many does it have? 1, 2, 3, 4. Great, so that carbon is neutral, okay, which means we don't need to write anything, no plus, no minus. Let's look at oxygen. How many does oxygen want to have? Oxygen wants 6 valence electrons. How many electrons does it actually have? Again, 1, 2, 3 bonds, that's 3 electrons. A lone pair is another 2, that's 5. 6 minus 5 means we have a 1 or a plus 1. So what do we have to do in this case? We have to make sure we indicate that the oxygen has a plus sign right there, which is already shown. When you do the same example here for the oxygen, does this have a full octet? 2, 4, 6, 8. Yes, that oxygen has a full octet. Okay, what about our charge? Now the bonds only count as 1, 1, 2, 3, 4, 5. Oxygen wants 6, it only has 5. There, that's got a plus 1. So what do we have to do here? We have to write a plus sign right there. So that oxygen has a positive charge. This oxygen, both of these oxygens have full octets, but they have a positive charge, okay? So what you see here is oxygen only has 5 electrons because it's forming 3 bonds in 1 lone pair, therefore it has a positive charge. It's not bonding in the way it normally does, which is 2 bonds and 2 lone pairs. Therefore it has a plus charge. All right, and the last example we're going to look at here, we can look at our oxygen. Let's look at, does this follow the octet rule? A bond counts as 2, 2, 4, 6, 8. Again, that follows the octet rule. Great. Let's look at formal charge here. How many does oxygen want to have? Oxygen wants to have 6. How many does it actually have? Again, the bond counts as 1. Here we have 2, 3, 4, 5, 6, 7. So now the oxygen actually has 7 electrons. So this is a negative 1, right? So we never write a negative 1 here. All we have to do is just write a minus sign right next to that O. Okay, so because oxygen is bonding differently than it normally does, it's forming 1 bond and 3 lone pairs, it has 7 valence electrons. Therefore, it has a negative charge. Okay. Going back to the sort of question, what atom could I replace this oxygen with where it would be neutral? What likes to form 1 bond and 3 lone pairs? What likes to have 7 valence electrons? And if you remember from above, that's going to be a halogen. Okay, so if this was R to F, then it would be neutral. Or R to chlorine, that would be neutral. All right, and just real quick, we use this letter R. That just means it's some atom, usually a carbon or a hydrogen. We use the letter R to indicate that's attached to other things. We don't really have to worry about it too much. Okay, so kind of reviewing here, right, we're learning 2 different ways to count electrons. So the main skills, we always have to know how many valence electrons things have. Carbon 4, nitrogen 5, oxygen 6, halogen 7. That we just have to know, okay? We kind of then need to know, by following this octet rule, then we know how do they want to bond. Carbon wants to have 4 bonds and no lone pairs. Nitrogen 3 bonds and 1. Oxygen 2 and 2. Halogens 1 bond and 3 lone pairs. That's how these atoms are going to bond to be neutral, okay? And again, we count electrons for the octet rule. Bond is 2, lone pair is 2. Okay? And that really helps us draw structures properly. Thinking about electrons and the octet rule allows us to draw structures the right way. Okay? But a lot of the times when you draw structures, we're really going to have to be always worrying about calculating formal charge. If an atom has a plus charge or a negative charge, we always have to show that, right? We have to show the plus or we have to show the negative, okay? So Once you learn and feel comfortable drawing structures the right way, we're not really going to be counting electrons for the octet rule all that often, right? We'll do it in the beginning, but once we're comfortable drawing structures, you're going to see we're going to have to be calculating formal charge a lot more, okay? So we're always going to have to be thinking about formal charge, especially when we start talking about reactions and we start seeing these intermediates where carbon or oxygen or nitrogen have plus charges or minus charges.